It's like 950 ohms right there. All right, we got 3 multimeters here. We got the one on the left, which is the amount of voltage in the battery. And we got the one in the middle, which is the output of the SSG circuit. And then we got the one on the right, which is the output of the SSG gen mode circuit. Now what I'm thinking about doing is running these batteries in parallel or series for 24 volts and parallel for the extra capacitance, the extra runtime. I mean, if the goal is for it to run, look at that. Play with the resistance a little bit, add 50 resistance, it wants to go up. So it went up to 1199 from 1198. Or it wants to. So it's like right on the brink. So let me explain the circuit from beginning to end. Right now we only have this one battery involved in the circuit. So it goes battery to SSG. Let me explain how the circuit's hooked up though. You got this coil hooked up to this circuit. You got a potentiometer hooked up to this circuit. Then the output of this circuit goes to the input of that circuit over there. And that circuit's hooked up to another coil that's over here. So it's got its own coil, and it kind of balances out the output. The it balances it out a little bit. You get more out of this one when you do them separately than when you do them together, and you get less from that one when you do them separately than when you do them together. And I'll explain that on the multimeters in just a second. So the output from this circuit goes to the input of that circuit through a cap bank. Keep on leaving the cap bank out. I can't do that. It's like the key component to making all this stuff connect together without, switching and all that. It's the main, because it's rectified. It's directionally attuned. It's what makes it flow the way it does. It's not like this cap bank, which is just a cap bank with some resistors on it in series. It's a great cap bank, but this other bank, that it has bridge rectifiers in it. It has 4 bridge rectifiers. It has AC caps on one side, DC caps on the other. So it flows in as AC or DC, because the AC caps will hold the energy will go through them. It just won't react the same way. But yeah, it'll go straight through that. The DC will go straight through this, and the AC will go and get converted to DC if it tries to go through there. So, yeah. So we go output. All right, we'll start over again. Battery to input. Output to cap bank. Cap bank to input. Okay, so the loop doesn't end at one circuit. So it goes from the cap bank, instead of going back to the battery, it goes to the input of the next circuit. And then the output of that circuit goes to another cap bank. And then that cap bank is connected back to the battery. So you have two circuits, 2 cap banks, 1 battery, 2 coils. Right now there's only 1 potentiometer. I think it's 680 ohms on the other circuit. So that could change. And there's about 950 ohms of resistance on the potentiometer right now. And that number's looking pretty nice, but the wheel's starting to slow down. And I think if it slows down too much, it will let go. Like if that number starts going up, like 200ths in like 10 minutes, man, that means it's shut off. And I should be able to hear it shut off because the fan's not running. Yeah. So I mean, we could get it going fast, but the way it's set up, it'll spend too much. I'll even do it real quick. So it's at 950. Let's turn it down to 500. So it's dropped to 1198, but I think it'll level out for a while. 1197. Might keep going down though. We'll see what happens. I can always fix it, you know. So, but it is constantly spending, and it just seems like with the 12 volts, with this particular mesh of components, no matter what I do, whenever I release the resistance or reduce it, so it'll go faster. Yeah, we start having issues with keeping the unity going. So this is 500 ohms, and then 680 ohms on the second circuit. So it's weird how many, like, literally, I think about 1,000 ohms on each circuit would be great, you know, and for what I'm doing, it would be perfect.
Building a brand new matrix.
That's right. And this is the brains of the matrix right here, man. He's dizzy. The brain is very dizzy.
Flux capacitors out. Flux. It was a comment that actually said.
Oh, that's right. That's right. Hey, I want to put this on here, but it's heavy. So, I mean, if I do this, oh wow, it's sucking. This is an iron infused PLA core. Yeah, I can feel that, dude. I don't know if I want to do that. Ooh, it's like. Yeah, if there was a coil wrapped around this thing, that'd be going off like rapidly.
How long did it take to do all of this? It looks like a mainframe for a SpaceX project.
That's a difficult question. I did this in about 30 minutes. But it took me years to make and accumulate all the stuff to do it with.
Yeah.
So at 50 or 500 ohms on circuit 1 and 680 ohms on circuit 2, we are at a rapid descent. We started it at, well, no, actually, no. We started it at 11.99, 11.98. So we lost 2 100ths at 500. Maybe we'll leave it on there for a little while and we'll see what happens. I was suggested that I don't even start taking real readings until like 10 minutes in of having it be running for 10 minutes. Because, I mean, the battery's got to adjust, I guess, to it being hit from both directions. But I'm telling you, with the cap banks in there and the bridge rectifiers and everything, it kind of flows really nicely. And there's lights on the cap banks that indicate how well they're working. And when they're really, and they're not really bright right now, but when they get really bright, that means that the flow has stopped and it's starting to collect in there. But this is designed to have what I call throughput. You know, it's not designed to really capture the energy. It's designed to send it through as DC. So you can have AC or DC go in, but DC is coming out. And then another thing that would work well with the cap bank here is this high voltage DC to DC transformer. It gets up to 345 volts of DC electricity. And when you're working with something that needs voltage, 345 is quite a bit. It's late night with Papa Bale. What's up? So each circuit has its own coil. There's 1660 turns of 20 gauge on this coil, or this circuit, and there's 1460 turns of 20 and 22 on the other circuit. So there's 730 of each, 20 and 22, in series. This one's in series too. There's 830 turns wrapped parallel, but I put them in series. And then there's, I put the trigger strands in series, so there's 1660 turns of a trigger strand in this one as well. And whatever bifilar things are going on, it's going on to the full extent in this coil. Because I got everything hooked up in series, so it's working good. The other coil over there's got a 30 gauge trigger strand, but it's just working off the energy from this circuit. So the battery goes into this one, and the energy that comes out of this one goes into the cap bank and then is fed to that one. And then what comes out of that one is then put back into the battery through the cap bank over there. So I'm definitely going to have to draw a picture. I said I was going to. I didn't get around to it yet. But I'll definitely do that. It's really simple. It's really quite simple. If you start at the battery, you end at the battery. So you go here, here, there, here. You can use any coil you want, really. Mike suggests that you use 380 ohm coil, and that is probably a good suggestion. I would take his word for it. 380 ohms. I guess you can use whatever gauge you want. It just matters on the resistance that coil has. And then if you're working with frequency, it doesn't matter as much, because from what I gather, all that resistance is going to go away once you get it vibrating at a certain frequency. And that everything is motion. Okay, light is motion, sound is motion. It's all vibration. It's all frequency, and that is motion. I don't know how else to put it. It's all motion. It's all friction. It's all, you know, if it's not moving, does it exist? Yes, absolutely it exists because everything else around it will be moving and running into it. So yeah, and I don't even know if I've bumped into a situation like that in my life, but I'm pretty sure those pitfalls do exist. And then blessings come the same way, I would imagine. Or good luck, or whatever you call it, man. When you're on a winning streak of any kind, man, that's a blessing. And in the same token, it can be a curse too. So I mean, I guess moderation maybe is key. I don't know. But I do know that if you yeah. I'm sorry, something just went through my head that I'm not gonna say. It went through my my head, but I'm not gonna say it. It's pretty funny though. Let's think here. So this is the closed loop dual circuit dual coil. So there's two coils here, actual bobbins, not just my dual drive coil, but there's two coils here hooked up in series to each circuit. So it's roughly the same amount of copper going into each one. And I think 1196 we've settled in at 500 ohms. So this could be our new speed for a little bit. Yeah, but like 11.5, I'm turning it off, and it's gonna take forever to get there. I know, but I gotta charge it up then. I'm gonna use a wall charger. I'm gonna leave it plugged in till it charges up. So, yeah, and I've done it twice already. I've used up the juice to the point where it was not worth using the battery at that point, and just took it out and charged it up at the wall. Sometimes I run these things and they just kind of overnight they'll sap out to get low enough that it's kind of like, okay, I'm gonna change it up. But that's pretty good pace, 1196. Hopefully it'll stay like that for a little bit. Let me look at the clock here. Yeah, so I'll go through what the multimeters are here in a second. All right. So we've got the battery. It's hooked up to this multimeter. The output of the SSG is hooked up to the middle, and the output of the SSG gen mode is hooked up to the right. And what that tells us is how much energy is being passed on to the next circuit. There's a little bit more energy going in, it looks like, to this cap bank than there is being drawn out, because the lights are on like a little bit, so that means there's more energy in the cap bank than's needed on the other side. If that makes sense. And then the more energy you have in the cat bank, the brighter those lights are going to be. So that's kind of what I'm saying. Let me think here. With the small amount of voltage coming out of the SSG, we're getting a lower reading on the SSG with gen mode because less energy is going in, less energy is coming out. But it's still 6 volts coming out, and it looks like it's 1.3 going in. And I believe the gen mode harvests the negative spike. It utilizes a reverse diode in the line to capture back EMF, I do believe. I mean, you can check me if I'm wrong, but I do think the gen mode is designed to capture back EMF. And so I put it on the end of the SSG thinking that maybe I could turn this tiny bit into a bigger amount before I send it back into the battery. That was my thinking. But so far it's been pretty much the same deal all around. But you know, it looks like we've hit something. It's been like that since the stream started. But they do hit these plateaus, and they will stay at the same digits for days sometimes. I've had one do like 48, 72 hours at the same digits on the battery, and then it'll start to drop. Now, why would it go for like 3 days and then start dropping? Well, it's not stable. What's keeping it going at the same rate isn't stable. I mean, the circuit might be stable, everything might be put together properly, you might be doing everything right, but it's a chance in purity if you can't control it. If you don't have control, then it's not even real. You got to find a way to control it. And I do believe it's changing. It's going down. Yep, just starting to change. It lasted for a little bit. Should I tighten up the resistance? See if we can get some of that voltage back now. I think that's what I'm gonna do. I'll tighten it up halfway. 720. Like 750, 720. So when you tighten up the resistance a lot, I find that we gen less, but we draw less too. So the resistance is on both lines in this SSG circuit, which is good to have it on the trigger and the drive string. It's all kind of, the way it works, it's all kind of done for you. All you have to do is insert, where it needs to go. Your wiring, you gotta wire it up. Then it's pretty plug and play actually. We're going up now. Wow. Oh, that's cool. I'd rather talk to myself all night, actually. So I'm gonna keep talking because I like doing that. But I do wanna over here and partake for a second. Everything in there?
I think it's good. This is good. What'd it do, Jesse?
Well, what I find significant about what it does is it runs and it charges the same battery that it runs from. At a declining rate, but it still keeps it going, you know, longer than it would be. It's like an alternator, kind of. So I put about as much resistance on as I can. We're up to like 950 ohms. I mean, what I could do is I could put a resistor on there and take the potentiometer out, or I could put a resistor in the front, move the potentiometer down one, and then we could start at like 680 ohms, and then we could put the potentiometer on, which would give us 1680 ohms
Holy Johnson.
with 1,000 ohms of variable resistance. That sounds fun. Actually.
Holy Jackson. That's a fun variable ohm 16 hundo.
Yeah, I get passionate about stuff sometimes, so I mean, don't mind me.
Do not mind. Like and subscribe. I always wondered if a battery could run a motor to spin an alternator to charge the battery.
With other components, I'd say it would be possible.
Josh is in the house.
At a declining rate, I would say it's not gonna go up like you're charging it with by the wall, but it won't go down. Is what I'm saying. And that's pretty much the best that we can hope for at this particular moment. Now, you can tighten up resistances and it'll go up, but it's always spending. That'll change. It only lasts for about 15, 20 minutes. Or sometimes longer, but it'll go down again. I always get excited when that happens, and then I'm like, well, I know what's really going to happen. So, and so far, self looped systems, they deplete. They don't really charge. They just deplete at a slow rate. But yeah, You charge for sure. It's just that you spend more than you charge with this type of system. Now there should be some. I think that circuit over there is a gen mode circuit, and you collect the negative spike or the back EMF with the reverse diode. It's already in the circuit. That's why we're getting so much voltage on the output.
Would a counterweight help?
Help what? What help? Would a counterweight help what? Maybe. I'm not gonna say no. I don't know. What is it for?
Is this a homemade record player?
Goes a little bit faster than that, but thank you. All right, let's see if it'll go with this many ohms on it.
Would a counterweight help to keep the velocity up?
Oh, that's so cool. We got a 680 ohm resistor in the slot. So that's our base resistance, okay? And then we got 1,000 ohm potentiometer on top of that. Oh, this is gonna be awesome. Yeah, our voltages are woo sweet. Let's turn it down a little bit. So we're at like 500 ohms on top. So like 1100 ohms, 1150 ohms, 1180 ohms. That's so cool. All right, so we go from this battery into this circuit, which is connected to this coil. And this potentiometer is connected to this circuit. That has 680 ohms on it. And then we got the output connected to the cap bank. And then the cap bank is connected to the input of the SSG gen mode. And then the output of the SSG gen mode. And the SSG gen mode is connected to a completely different coil. It's just being powered by the SG output. And then the output of the SG gen mode is being filtered by a cap bank and directed back into the battery. But I think we're spitting out a little bit more than we're putting back in of the battery. But I'm telling you, if we didn't have it hooked up this way, this battery would deplete so much faster than it is depleting now. I mean, there are different styles and different ways of hooking it up which will deplete it slower, like setting up a relay. Relays are a good way to prolong battery life as well, and when running a system. I think you can get the battery to last a lot longer with a relay than you can with like a closed loop system. Thusly. I haven't gotten the coils to be 380 ohms or anything like that, so I have yet to do that. 380 ohms, ladies and gentlemen, that's what you want your coil to be. So if you're going to do 20 gauge You're talking like a 20-pound coil. No, I'm more like probably a 8-pound coil, something like that. I should try the ohm tester on this total length 20 gauge. It's 1660 turns. I haven't got an ohms reading on it the way it is. But I can do that later. See, now it went back up to 11 and now it's fluxing. It's going up. It'll go up now that I tighten the resistance. But it wants to go down and it continues to go down. So, but like I said, it'll last for like 20 minutes.
Would a relay be timed to come on and off to save battery juice?
Yeah, relay that's kind of what it does. Prolongs the battery life. A relay like this anyway is designed to swap back and forth. This isn't a relay, but a relay is designed to do that, yeah. This is a closed loop system. This is and we'd probably be doing better if we had a potentiometer hooked up to the second circuit as well. Right now there's 680 ohms on that circuit flat. So there's 680 ohms on both circuits, and then there's a potentiometer on top of that on this circuit. Why so much? Because I like to keep my stuff within like safe, workable, parameters. Now we're going to spin like crazy, but we're going to start moving faster. So I moved the pot all the way over to make it like zero resistance. So we're at 680 ohms right now. And 1198. So we'll see how long it takes to get down to like 1197. How about that? And the relay that I'm specifically talking about is the magnets are 180 degrees, so the magnets go like this, and the coils are at 90 degrees, so they're like this and like this. So like that. So when the 80 degree and 180 is like this coil's on. 180 is like this coil's on. When one coil's on, the other coil's off. And you just, you swap the output of each transistor to the other battery. And it kind of like swaps the energy. It charges it when it's off. And, it runs really well. And you don't need a relay. It's all based on position. It is a relay. It functions exactly the same way a relay would. Oh, yeah, that probably happened a while ago. 1197. So, like, without resistance, it spins pretty rapidly. You would think it would be generating more, making more electricity without the resistance. but it's negligible. It's negligibly more. Now, did I set out with an idea that there's some kind of benefit involved in doing it this way? No, not at all. I just wanted to hook it up. See, first of all, if it would work in the first place. And second of all, you know, like, second of all, is there a possibility for some kind of discovery here? Not really. And that's how I like to do things. I don't like to, you know, I don't know, pen and paper. You know, I really never did much pen and paper stuff. It was all kind of, I mean, I did what, I played the game, I just never used the pen and paper. But now my memory is totally shot. I wish I would have wrote stuff down, kind of thing. But back in the day, I was right on, man. I snapped my finger and I could tell you exactly what was going on.
Sharp as a tack.
Sharp as a tack.
But now,
Now it's like, whoa, what?
where'd I put my keys?
Yeah, where's my stuff at? I lost my screwdriver. Oh, it's in my pocket. You know, that kind of stuff. Happens too often now. Oh. So we'll tighten it up a little bit. I think I'm going to leave it like this. I think it's moving really good for everything that the one battery is doing right now. I think this whole system is very fluid for how many components it has. I think everything's running so smoothly that I could probably leave this running and go to sleep. You know? And I count that as a blessing, considering how like rudimentary everything is and how, you know, like ghetto. I call this kind of a ghetto setup. Just not. It didn't start out that way. You know, it's how I treated it and how rapidly I went through different experiments and stuff like that, and how I don't. You know, the coils. If you put them away, they're probably going to end up breaking. Your ends will probably end up not surviving if it's a thin end. If you put them all in like a box or something like that. So, you know, storing of the coils is it's good to like just put one layer in a container. So I have thin containers and just put a layer of coils in there. It depends on how many coils you have, and if you even like take them apart or whatever. That's what I need, because I can put the coils in there and then the ends won't get messed up. Because it sucks, man. You got this whole coil like this, and you got one of your trigger ends broken off from the start. So there's no way to unwrap it to get more. There's no way to do that. And it's like, that's 4 pounds of copper. Or, you know, whatever. It's like, whatever, how many pounds of copper it is. And it's all because you tightened the nut when you were, you know, wrapping it just a little bit too tight. And it just snapped. From the start, it was already broken.
Just,
Yeah. Yeah, man. Bad oregano. Yeah, it's bad oregano.
oregano. But we like oregano. Good oregano. On the sauce, on the pasta, on the subs.
Because the same problem happens when you don't include the second circuit. There's like, because I heard somebody ask, why do you have the second circuit on there? Why don't you just run a closed loop with the one circuit? I'm like, because it was like that before I added the second circuit to it. And first off, it was all inside this coil. So about a total of 10 volts was generated between the SSG and the SSG gen mode through this one coil. So I don't know, man. Maybe it's better like that. Maybe I should hook that back up. Maybe I should do that for the next one. Have the dual, have all the input output hook up the same way, but have the coil hookup be all this coil right here.
Johnny is in the house.
What's up, Yanni? How's it going?
Josh says that it happens to us all, man. We all get the whole brain stuff.
Oh, all right. Yeah, man. It's awesome. You're sitting there and you're like, I got it, man. I got the key to the universe, and it's man. Damn, I hate it when that happens.
I got
Wish I would have wrote that one down. So this has got a total of like 1,580 ohms on it right now. And that's just this one circuit. 1,580 on this circuit and 680 on the other circuit. You can tell that it doesn't like that very much. But what's the 1199? So it's gone up 0.02 of a volt just from tightening up the potentiometer. I'm going to loosen it up now, get some speed. But then we spin like rapidly. But I got a resistor in front of the potentiometer, the 680 ohm resistor in front of it. So we can turn the potentiometer off and still have 680 ohm resistance. So I mean, this I can see how that, the word unity would come up, because I mean that number just really doesn't budge unless, I've done a lot of experiments where it takes a long time for it to move. Like this isn't one of them. Closed loops tend to deplete pretty fast. But I don't have a 380 ohm coil that I should probably make one. I'm thinking I want to make it that coil about a 24 gauge with a 26 gauge trigger. And have it be pretty big. I'm pretty sure it would be pretty big. Because the 32 gauge coil that I run my solid state drive, it's 12,960 turns at 32 gauge, and it has like 645 ohms altogether in series. So it's like 4,230 turns 4 times in parallel. So it's a 4-filer coil, 4,230 turn, something like that. but I got it all in series right now for generation purposes. About 1180 ohms right here. And then I keep on forgetting about this 680 ohms over here. See, but that speed right there is nice. It's comfortable. It's pretty. It's right around where it needs to be, in my opinion, with what's going on with it. There's literally like 1,200 ohms of resistance on that, and then look at how fast that's going. That's pretty good, I think. Because altogether, altogether, and I did it again. It's like 1,800 and something ohms. Literally almost like 2,000 ohms on here.
2,000 ohms. How many volts per circuit? Let's think about how to say that.
Huh?
How many volts on circuits?
It's 12 volts altogether.
I like this circuit.
It's like, no, man, that's not right. What's wrong?
And if it's wrong, then I don't want to be right.
It's wrong enough. Yeah. Yeah.
Oh man.
It's gonna be raining for another 4 hours.
So we're hovering right around 12 volts in the battery. 11.98. Right around that all night, really.
Alright, man, do a channel plug and a membership plug.
Yeah.
With the new changes. We just made some changes.
Yeah, we just made some changes for our membership. We decided to just make a single membership, and we decided to make it affordable. So that's a plus. And I've been using some splicing techniques for my short videos. It helps me take my long video content and spruce it up, so it divides it, and then I go in there and make sure everything's all right. So
Yeah, we're running a test, give some feedback on that.
yeah, we wanted to get exactly a feedback. So we ran it for like 2 weeks, and we were wondering what you thought of the new style of video. It's in the short feeds, so if you've seen any of those, let us know what you thought and any improvements that we can make. Did I leave anything out, bro?
Like and subscribe. Thank you for dropping in.
Oh, yeah. Hey, like and subscribe, everybody. Thank you for coming in. I really appreciate it. So we're at 11.99. It's actually going up right now. It's charging. That's amazing. It's amazing. It's a closed loop system and it's actually going up again. I mean, I tightened it up from one. Yeah. But I think it'll go down. I don't know what's happening right now. It's like right on the fringe. Peace out, though. Have a wonderful night. I'll check you later. Bye now.